What is crack lacking, gangster cowboys? Now before we start, I'm going to show you what we are going to create. If I hit the play button over here, we have this trapped maze wherever we are, but we can cut our way through it. Look at that, amazing. And now I am free like a bird. But anyways, yeah, we're going to create this effect where we will be able to cut everything. And this doesn't mean that you will be able to cut vegetables for your grandma. Don't call her and tell her, hey, I'm going to cut your veggies on Unreal Engine. No, but you get the point, okay? So there you go, cutty, 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 cutty. Anyways, this is what we're going to create, and I will see you in the creation part of this tutorial. Okay, my fellow cowboy, before we start, this is an intermediate tutorial, so for all beginners who are following this, don't complain that you don't understand certain things. And also download the project, link will be down below in the description. Click and go on my website, subscribe, and you will get the project so you can follow along with this tutorial because everything is already prepared. Over here, I have a third-person character that if I go here and hit the play button, I can shoot. Let me just lower the volume so that we can actually follow the tutorial in peace. So yeah, there you go. We can shoot with whatever these projectiles are. And now we are going to be able to cut all of this and then shoot the cut out part. So we're going to start over here inside the BP first person character, which is located here in the content, and then mesh cutting example, and then blueprints, and then over here. There you go. So it's right there. So the first thing that I'm going to do is right click and create a custom event, and I'm going to call this one start cutting. This is, I'm going to call it. I'm also going to right click over here and I'm going to say stop. Actually not stop cutting, but again, custom event, but the name of that custom event is going to be stop cutting. So this is what I'm going to do. Okay, there you go. Hit the compile and save. And before I also do that, I'm going to go here in the window, developer tools, and widget reflector. This is what I like to do because here you can scale the application, essentially scaling the editor, as you can see over here. So the higher this number is, you know, the bigger the editor is, if that is of use to you. So when we start cutting, first I'm going to say over here, flush persistent debug lines. This is basically going to remove the debugged lines that we draw previously when we cut our, or when we, yeah, cut the part. Whatever, the mesh, how is it called? Anyways, so also what I'm going to do is take this box over here, which is under components tab. So I'm going to take that bad boy, and from here I'm going to say set collision profile name, which is going to be basically, or it is going to determine the collision profile in terms of, does it collide with something? Does it not collide? And so on and so forth. So over here I'm going to say overlap all, meaning it will overlap everything it touches. So yeah, it can collide with everything. Over here for the stop cutting, and this was for the start cutting. For the stop cutting is where we are going to cut everything after we have finished cutting. So over here I'm going to go in a sequence. And the first thing I'm going to do in this sequence is go inside of a branch. Now for this branch, we need a couple of variables. And these variables are going to be over here on my left side. So 1, 2, 3, 4, and 5 variables. So over here, the first variable is going to be our box origin. There you go. And the box origin is going to be a vector. This one over here below the box origin is going to be the box rotation, and this one is going to be the rotator. Next, after rotator, we are going to have the last impact location, or basically where we last cut something, and that is also going to be a vector. And this one is going to be is cutting, which is going to be a boolean to determine if we are cutting or if we are not cutting. To cut or not to cut? That is the question. Anyways, the last one over here is going to be our box width, and this one is going to be a float. So let me just find the float here. Let me compile and save that because I want to take this box width and over here for the default value, set the value of 5. So make sure over here for the box width to set the default value of 5. So now what we are going to do inside of this branch? Well, in the branch, we are going to test if we are cutting and not setting, but getting. And over here, we're going to test if we are cutting. Now, before I proceed to do everything what's gonna happen here inside of this branch, over here from the second sequence. So the sequence functions like this. First we do this, then we do this, then we do more sequence. If we have here more, we can do more, and there you go. I don't need more, I just need 2. Now over here, what I'm going to do is I'm going to set is cutting to false, is okay, as you can see over here. I'm not going to check that checkbox. I'm also going to get the box again, and I'm going to set the box extent, and the box extent is basically the size of the box. So over here, I am going to plug this in like that. It goes over here for the box extent, and update overlaps, that can be checked. And from here, I'm also going to set collision profile name like that. And I need to attach the box, but click on the node so that we can set it like this and we can see it. And over here for the collision profile is going to be no collision, and there you go. This is what the collision profile name is. Basically, it is going to set if the specified box in this case can collide with something, or if it cannot collide with something. So this is what we are going to do when we stop cutting. First, we are going to execute everything that's going to come right now, and after we execute that, we are going to set that we are not cutting, change the size of the box, and over here set the collision profile name. That will be it. So what's gonna happen inside of this branch? Well, if we are cutting, if that is true, we are going to draw a debug box, which we are going to use to preview how that cut is going to look like. And for that, I'm also going to use the box, and I'm going to get the world location from the box. It's location, not locatin. It's location. There you go. And from here, I'm also going to get the scaled box extent, which is going to get me the scaled of the box. If I basically hover over, it's not going to display anything, but essentially, as I said, it's going to get the size of the box. I'm also going to go over here and get the world rotation, if it allows me to do that. There you go. So over here, I'm going to plug this in. The location is going to be the center. The extent is going to be the extent, or the size of it. And this is going to be the rotation of the debugging box that you are going to draw. Also over here for the color, you can set whichever color you like. I'm going to set this bluish, whatever color this is. Now next, what I'm going to do is get the box again, and from it I'm going to get all the overlapping components. So get overlapping components, and from here we are going to go inside of for each loop, and that loop goes here. This one goes here. And what is this get overlapping components? Well, because we set over here the collision profile name to be overlap, the box will be able to detect collisions with everything that it overlaps. So get overlapping components returns unique list of components. This component is overlapping, basically. So that would be it. Next, over here from the loop body, I am going to cast to procedural, if I can spell that, mesh component. This is what I want, and I'm casting the element from the array. So I'm casting it into the procedural mesh component. Basically, procedural means it will be generated on the spot. And from here, I'm also going to go in a loop. So for loop, not for each, but for loop, like that. First index is 0, last index is going to be 3. And from this loop, what I'm going to do is I'm going to slice the procedural mesh. So all the way over here, I'm going to say slice procedural mesh. And the mesh that I'm going to slice is going to be this one over here. So let's go and plug it in, but I'm also going to set this node so that we can see it more clearly. This is the baddest part when it comes to coding with nodes. And yes, this is coding as well. This is visual code. Everything we do here can be translated to C++. And if you want to learn that, link is down below to join my academy, okay? Now, what we are going to do over here is get the box one more time. And every single time we use the box. So over here from the box, we are going to get the world location. This is one thing that we need from the box. We also need get the right vector. So we also need the right vector. We also need the scaled box extent from the box. All of this info we needed. And from here we also get the forward vector. So the world location, right vector, scaled box extent, and the forward vector. This is everything what we need. Now for the scale box extent, I'm going to split the pin structure so that I have access to individual axes X, Y, and Z. From here, I'm going to say minus vector like that. So we are going to subtract from this vector and we will see what we are subtracting in a moment. Do not worry about that. We are also going to have over here plus vector. So first we are minus, then we are plus, then again we are going to be plus over here, and one more time we are going to be minus over here, and all in every single one of these scenarios the world location goes in the first pin. Okay, so the world location goes in the first pin, and can I do something like this? Put it over here, then it can go here, then it can go here, and it can go here. So there you go. And all of these point to the world location, actually. Probably moving a little bit here. Voila, there you go. And this one can be like this, so that these don't obscure. This is spaghetti node. So not code, but spaghetti node, okay? So what are we going to subtract and add and whatnot? Well, from here, I'm going to say multiplied with the float, and the right vector is going to be multiplied with the Y axis from the box extent, and that goes over here in the minus. So it goes here in the minus, but it also goes here in the plus, okay? So it goes in both of these. What I'm also going to do is take the forward vector and I'm going to say multiply with float, and this forward vector we're going to multiply with the X value from the box extent. And over here, this one is going to be plugged in inside of here and also inside of there. Now you can also click it like this, and this one goes here, and there you go, so that we know it points to 1, and do the same thing for this one. So it goes here, but it also goes here. There you go. So this is, I believe, a little bit more readable when it comes to all of these nodes. And next, what we need to do is from here, let me move this just a little bit forward. There you go, over here. From here, I'm going to call a select. There you go. And this select works in a way that we, based on the index, we are going to select the option. So option 1 is going to be the minus over here that we have as a result. Next over here, option 2 or option 0 is the minus, option 1 is the plus. We're also going to have 2 more options, so every single one of these is going to be plugged in there. And for the index that we are going to use is not going to be the wildcard, but it is going to be the index from the loop. So I'm going to take this index and also set it like this so that we can make it a little bit more readable. So based on the current loop that we are in, and we're going to loop from 0 to 3. Last index is 3, and you can see over here we have all of these options, and these are going to be plugged into here, into the playing position. So compile and save everything what we did so far. Over here we're going to click on create. So if true, additional procedural mesh component will be created, basically means we want to create additional components or procedural components that we, from the ones that we slice, okay? We are also going to go here, use a last selection for cap, in if and how to create cap geometry on the slicing plane. Just think of it that this will create a new mesh. That's the simplest explanation. We don't go in the math behind this. If you're interested in math for game dev for Unity and Unreal Engine, let me know in the comments down below and I will create those videos and post them here on YouTube, okay? So moving forward, I'm also going to go here at the bottom, and we are also going to use the box one more time. And from the box over here, I'm going to get the right vector. So this is one thing that we need. And we also need the forward vector, because over here we have two parameters. One is going to be the plane position and one is going to be the plane normal. To calculate the plane normal, we need to use the right vector and the forward vector. So from here, what I'm going to do is multiply with the float, and this float is going to have a value of 1. So this one's going to be multiplied here with the value of 1. And over here, I'm going to copy and paste it because we are going to multiply this with another vector, but this vector is going to be multiplied with -1. And moving forward, over here, I'm going to copy and paste that, because we are also going to multiply the forward vector with -1 over here, and then again copy and paste and multiply this vector over here with 1. There you go. So both of these are going to be multiplied with 1 and -1. 1 is the positive, -1 is the negative. So right vector multiplied with 1 is going to stay the right vector, and right vector multiplied with -1 means the left side. Forward multiplied with minus means backwards, and you get the point. And from here, I am going to again go into the select, and we are going to have 4 pins. So the first pin is going to go here, and I'm going to select all these, move them a little bit down. So the first pin is going to be the one that we multiplied from the positive. The one multiplied with the right vector with the negative is going to go on option 2. This one multiplied with the negative is going to go in option 1, and this one is going to go in option 3. And here, same for the index, we are going to use this one. So let's go, and let me just adjust all of this here like that, so that it is more visible, more clear what we are doing. In these situations, I recommend adding comments. You can take this one section and move it down. And this one is going to calculate the plane normal. And then for the plane normal, we're simply going to return or plug in the return value over there. And that would be pretty much it, like that. So compile and save that. Now, of course, we are still not done, because there is more thing that we need to do, which is over here when the loop completes. So when the for each completes, I am going to get the box again. And from the box, I'm going to set the box extent like that. And this one is going to go here, but I'm going to move these down to here, something like that, so that it is more visible and we know what we are doing. There you go. And it can be probably moved somewhere around here. So we're going to set the box extent by using the scaled box extent. So from here, get scaled box extent. There you go. And I'm going to multiply that. So multiplied with the float. And the float is going to be from here 0.95, so that it reduces the extent by 5%, and it's going to be plugged into the box extent. We also are going to get the box one more time, and not this one, we don't need this, but only need the box. There you go. And from the box, we are going to get the overlapping components, not the actors, but the overlapping components. And from the box extent, we're going to go into the for each loop. And the array that we are going to loop is the all overlapping components that we have overlapped with the box, and we are going to cast every single one of them. So cast to procedural mesh component, and casting the element inside of that array. And we are going to set the physics material override for the target, who is the procedural mesh, to the PM bomb. And you can check that if you watched my previous tutorial with the dice. You saw what are physics materials and how can we create them and all of that stuff. So check it out. Just click here and it will be located for you, and you can check it out, and there you go. Also here, I'm going to set to simulate physics to true, and it will be plugged into here. This goes here, by the way, and from here and here, voila, so that it is more readable like that. And compile and save that, actually compile and save, not browse. So we're pretty much done with the functionality of slicing and all of that stuff. Next we need to go inside of the tick event that we still did not create, so we can take this all here and move it a little bit upwards. And if you like, you can select this here and move it a little bit upwards so that, you know, these two don't obscure each other. There you go. Compile and save. Next, right here, I'm going to right click and tick event. What's going to happen inside of the tick event is that we are going to enter the gate. And the gate is very good for a control flow, because we can open the gate, we can close the gate, and we can do things when the gate is open. So allows for opening and closing the gate to control the execution flow. So over here, I'm going to right click and filter for right mouse button. So what's gonna happen when I press the right mouse button? I'm going to call start cutting. So start cutting is going to be first call, which is this bad boy over here. And he is the one who is going to open the gate. So when we start to cut, we are going to open the gate. To close the gate, we're going to go here from the release key and into a sequence. And the first step in the sequence is going to close the gate. And of course, the gate is going to start close. And the second sequence is going to stop the cutting, because, you know, we have released the button, we don't want to cut anymore. Makes no sense for cutting, okay? So what's gonna happen from the gate when we open it is that we are going to enter a sequence. And when we enter this sequence, we need to do certain things, which is first locate where the mouse is and what the mouse, or the shape where the mouse is drawing and stuff like that, so that we can draw the box that is going to cut everything. For that, I'm going to use this sphere, actually not the sphere, the scene. Let me just find it, where it is. Here it is, the scene component. And from the scene, I'm going to get the world location. It's world location, like that. I'm also going to, let me just move this over here a little bit so that we can see better. I'm also going to get the forward vector, like that. And from here, from this, I'm going to say plus vector. So I'm going to add to the world location the forward vector, but I'm going to multiply it with a float. So I'm going to multiply first with the float. And the float that I'm going to multiply it by is going to be 5,000. So 5,000 units in front of me. And I am going to go from the first sequence and call the line trace by channel. Voila. There you go. Is this okay? Yes, it is. And this one is going to go into the start. So this is where the start is. Or actually, no, excuse me. This one goes in the end, and the start goes from the world location. So the world location of the scene is where we start, and the end is going to be forward by 5,000 units. Simple as that. Over here, ignore self and all of that stuff. That is totally fine. From the line trace channel, we are going to go inside of the branch so that we can test if we actually hit something. So do we have a return value with this line trace by channel? So the return value is going to be the condition. And from the hit over here, I'm going to break hit result so that we have access to all of these functionalities. If it's true, if we hit something with this line trace channel or line trace by channel, we are going to set the last impact location. It is going to be set to the impact point, or basically where we touched with this line trace by channel. And from there, I am going to drag a node and cast to procedural mesh component. And who am I casting? Well, I'm casting the component from here that we hit. So this goes over here, the hit component from the break hit results. And going from there in a branch, which is going to check if we are not cutting. So over here, get the cutting and not. So if we are not cutting, basically means the opposite. So we're essentially, are we cutting? So we're asking if we are not cutting. If that is true, we are going to set is cutting to true over here. There you go, because this is asking if we are not cutting. If that is true, so we are not cutting, we're going to set cutting to be equal to true. And from there, I am going to set the box origin like that, and set the box rotation like that. But what is going to be the box origin? The box origin is going to be the impact point. So from here, drag it and double click on this to create this node so that we can see it more clearly. So this is going to be the box origin. When it comes to the rotation, and I'm going to actually move this a little bit here, something like that, and double click it again and move it here, because first over here I need to get get actor right vector, which is going to get the right vector from the current actor, and I'm going to project vector on plane. So vector on plane projects a vector onto a plane defined by a normalized vector. Your assignment, even if you're a beginner or if you're advanced, I want you to check out what this means. I'm not going to tell you that. So I want you to check it out and see for yourself. And over here, for the plane normal, what I'm going to do is I'm going to take the impact normal and plug it in. And this one is going to go like this. There you go, that goes there, because now the return value we are going to use, and we're going to say make rotation from Y and Z, and the Y is going to be the return value from the projected vector on the plane, and the Z is going to be our hit over here, impact normal, that we get from the hit result, and that is going to be set for the box rotation. Compile and save that. Now, of course, we are not done, because over here, if you remember, we have a sequence, and this is the first sequence. So this is the first thing we do in this sequence, and the second thing we do in this sequence is we are going to set world location rotation for the box. So set world location and rotation. After we do all of this above, and I'm going to click on this here and move it like that. There you go. How are we, or what we are going to do to set that? Well, first things first, I'm going to get the box rotation. So get the box rotation and get the box origin. So we need these two. And the box origin is going to be the new location that goes over here. But what we are going to also calculate from here is we're going to say make transform, and from this location and this rotation we are going to make the transform, and we're going to use this transform. So move this over here, and from this transform I'm going to say inverse transform location. This is what we want, and the location that we want to inverse is the last impact location. So plug this bad boy over here. There you go. And next I'm going to break the vector that we have just created. So from here, I'm going to say break vector, which is going to allow me to have all of these inputs separated. And what's gonna happen for this one, and by the way, also over here for the rotation, we need to plug in this box rotation. So it goes over here, and let me just double click on it and move it over here so that we can see it. This can go here. Now what we are going to do with this vector is we are going to get the absolute value from the x-axis and absolute value, which is going to convert them into positive numbers, and we are going to make a new vector. So make vector like that and plug this in over here. There you go. And for the z, it's going to be the box width, which we are going to use to create a new box, so to say, or box extent with the width that is going to cut the plane surface that we have or on which we are drawing. So for that, we do need to get the box again, and from here set box extent. There you go. This one goes here, and the box extent is going to be this vector that we have just calculated. Overlap or update overlaps, that would be it. And the last step is to again draw the debug box. So draw debug box that we will be able to see, and in order to do that I need to, where did we draw the debug box? Here it is. Copy this and go here and paste it. There you go. Because again, we're going to use the location as the center, the extent as the extent, and the rotation as the rotation. And we also need to set the color. I mean, we need to. It's not mandatory, but you can do it however you want to do it. I'm going to set it to orange and just make sure that you compile and save that. And over here for the thickness, we are going to set it at 5 for this bad boy, and the duration is going to be equal to 0. And for the first one over here that we did not set, that I just realized, is that we're going to set the duration to 3 and the thickness to 4. So let me just compile and save that. And this is pretty much it, what we need to do. We can go now and test it out. So over here, make sure, first things first, compile and save, and over here, save. And now I can hit the play button and let's try it out. Look at that. Okay, over here I have cut too much. And there you go. You see, I can draw on it. Voila, 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 voila. There you go. There you go. Come on, move. There you go. We cut everything. So yeah, that would be pretty much it for this tutorial. If you like, hit the like button. If you want more tutorials, hit the like button, subscribe. If you want more advanced tutorials, go in my academy. Link is down below because I'm focusing a lot on Unreal Engine with much better tutorials like this one. This is just a basic thing that I put out on YouTube. But even this basic thing is better than most paid courses out there. There you go. I said it. Anyways, I will see you guys in the next video.